Alright everyone, we are up to 3.8, inscribed polygons. I'm going to make this really short. It's pretty straightforward. We should have a lot of time to work on this in class tomorrow. The concept we're dealing with is really a carryover from 3-7, where if we have externally tangent, that's what that's called, segments to a circle, that this length right here is the same as that length right there. And that makes sense. If you've got a bowling ball wedged into a sharp angled corner of a room, it's going to get stuck in such a way that these two sides have to be the same length. You can do a proof of this actually by indirect method, which we learned about today, by assuming that that's not the case, and you can see that by drawing these sides you get triangles that you expect to be congruent and aren't. So it's a nice little indirect proof of that one. If that's true then, and you've got a homework problem that's like this, and if you look at the first few, they're very similar to this sort of a problem. And we're asked to find the perimeter. So what is the perimeter of this? Well, knowing that this is the case, and we see that these are all tangent points, well, if this is one mark here, that's got to be equal there, and this has got to be equal here. And then these all are 7. Okay, so if this is 7, that's 7. Whoops, that's not 16, that should be 14. I didn't need to write that. My bad. 14, and then that's 7. And if this is 5, this will be the same length as this. This is 5. If this is 6 with 3 marks, this is 6 right here. And so the perimeter then is going to be, that's going to be 10 plus 12 is 22. 22 plus 28 then is going to be 50. Okay, so the perimeter is 50. Alright, well, the yellow box in the book that goes to this section has one new formula, and that's that we can find the area of any inscribed polygon if we simply know the perimeter and cut that in half. That's called a semi-perimeter. And then we know the radius, and suppose the radius happens to be, I don't know, let's say 6.5, just to stay away from a nice whole number. Alright, 6.5. Then we would just multiply the semi-perimeter times 6.5. Okay? And if you think about why that is, it goes back to the fact that we can make each one of these into a triangle there, and the radius is going to be perpendicular. And so we've got the altitude of the triangle, and then we've got the base of the triangle, and then when we cut that in half, that's why we've got the semi-perimeter there. So 25 times 6.5, I guess I'll let you do the math, and you can tell me what that is. Alright, so 25 times 6.5 will be the area of the polygon. Thanks.